Well, if angles can be bigger than 90 degrees, then just normal right angle triangle, of course, does not work. So the sine rule, which you might have seen before, here is random triangle. Let's prove the sine rule anyway. Drop in the perpendicular height, then using right angle triangle, we can say H is C sine B, but we can also say it's B sine C. Therefore, they must equal each other, and we get C on sine C is B on sine B. But of course, we could have picked any letter. So to complete it, we say, oh, well, A on sine A. And so the reality is, the extension of that is it actually equals the diameter of the circumcircle. Right? So the circle that you can put around it will also equal that particular ratio. Let's just do a quick little example. There's a sine rule. It's H I'm trying to find. So in this case, H over sine H is Q over sine Q. Subbing in, rearranging, bit of calculator work. And there we go. Notice how I put to 1 decimal place there. Of course, the other situation is we might want to find an angle. And all we do is take the reciprocal of the sine rule. It's easier to put what we're trying to find on the top. So I want to find angle Y. So sine Y on Y will be sine Z on Z. Again, substitute in, rearrange. I get an answer of 46 degrees 58. Now, I know that that is 46 degrees 58. There is another possibility, of course. What is the other possibility? But in this case, it's not. Why? Yeah. You can't have more than one angle being bigger than 90. So in this case, I know that, yeah, it definitely is the acute angle. So not an issue with here. But that does bring me to this. So does the answer make sense with your problem? In that case, it did. But could it be obtuse? Would it make more sense for the angle to be obtuse? So keep an eye out for that, because remember, your calculator will only give you acute angles out for sine. It might give you a negative acute angle as well, but it's not going to give you an obtuse angle at any point. So things to keep in mind: angle sum of a triangle, 180. The biggest angle is always opposite the biggest side, and the smallest angle opposite the smallest side, and so on. But have a look at this one. Here's ABC. This is what I was talking about with the circle. If you draw the circumcircle around, in fact, it will equal the diameter of that particular circle as well. That actually comes in handy in some harder circle geometry problems, because it allows you to bring trig into the question to allow you to solve some problems. Okay, area of a triangle. This is another formula we often use. Let's prove the area of a triangle formula. We, of course, know triangle, half base times height. So I could say it's a half A times H. But then I could also use trig to say H is B sine C. Combining the two together, we get that formula of half AB sine C. So it's always the included angle and the two sides, either side of it. So which means it could have been half BC sine A, it could have been half AC sine B. And another quick little question. So for this one, half DM sine F. Punch in the buttons, making sure your calculator is in degrees. And there we go, two decimal places. And notice the units, unit squared. Unit squared. All right. For H we'll play with.